let's turn to the last valuable session, because time is like which will be about encryption. Am I right?
Yes.
By Rodrigo, who came from very long place. Very long
originally,
distance,
yes.
From Brazil.
Yes.
Right? So we cover today Europe, Africa, and also South America.
Yeah.
Which is great.
I did not come today from there, but yes.
Because you
originally
started your trip a long time ago,
yeah,
right?
Yeah, yeah.
In Belgium. But
yeah.
I'm giving the talk to you to introduce yourself and your topic.
Thank you. Well, hello. What I'm going to present to you today is Drupal protected content. It's a Drupal module. I just contributed it to the community 1 month ago. It's a full project. It was previously a sandbox project, and then it grew enough to become a full project. Not yet in a stable release, not yet with a tag, just a development branch so far. Let me tell you a bit about me. As Balas told us, I come from Brazil. I was born in this very south region of Brazil, so a bit different from the Brazilian stereotype. We have some big mountains, even a bit of snow during the winter, 3,000 meters high, some mountains. And I live in Brussels for the last 2 years and a half. This project came from a need of a client that wanted security, so big privacy requirements that he was okay on not being able to access his own users' content. So this is okay. So the user himself is able to access the content, but the owner of the server is not able to do that. So the solution for that, and it is a very appealing solution because it's really strong in terms of privacy, that is client-side encryption and decryption, and also client-side generation of public and private keys. This way, we can be mathematically sure, or from common knowledge, we can be sure that no one will be able to access the content, even if this attacker gets over the server itself. So if the attacker has a super user access to the server, even though it will see only a ciphertext and not the plain text of that information. So it will be mathematically, from what is known today, impossible. This solution is a Drupal module that is a humble wrapper around OpenPGP.js. That is a library used on ProtonMail.com. ProtonMail, the guys developed that. They came from CERN, C-E-R-N, in Europe. There they started doing that, and then they left CERN to found their own company. And they are also over the shoulders of giants, because OpenPGP.js is a JavaScript implementation of OpenPGP. And OpenPGP is also over the shoulders of giants, because it's a standard now, but it does not enforce which encryption algorithm you are going to use. It enforces a use of asymetric encryption algorithm, but does not tell you which one. And the one we use, that OpenPGP.js uses by default, is for the asymmetric, is RSA. And there is one step in the process that is symmetric encryption, that is AES 256. So it's a lot of stuff. I'm not a specialist on encryption. I'm working with Drupal for the last 10 years, so I'm kind of specialist on Drupal. And I needed to learn a lot of things about encryption to get into this project, to understand how was the process, which was the workflow, to be really sure of what I was doing. So in this presentation, I made it split in 3 parts. I have, I think, 14 slides. 14. The first ones, they have some screenshots and some explanation of the model. And they will present the workflow of key generation, file not really upload, because the file does not get really uploaded. This is interesting. The file is going to be encrypted in the client, and only the ciphertext resulting from that encryption goes to the server. So then, after this, user gets a link, access link, to be shared to the person that is going to get the information. Could be himself, could be another user, or could be multiple users as well. And then this is a screenshot. I'm going to review this later. I'm just going very fast over all of them now. This is where the person is going to type his encryption password to be able to access the content. The check of the password is interesting because this password is actually not stored nowhere. So the encryption password never goes to the server, as happens the same with the file itself. It never goes to the server. So what goes to the server is an encrypted version of the private key. So this password stays only in the mind of the author of the password. This is very interesting. Then, at the end, I have some information, some knowledge to share from a reading that is very nice, the code book by Simon Sine. He's a journalist specialized on science and mathematics, based in London. He writes great books. One of them is the Fermat theorem. He wrote that book, beautiful book. The code book, also a beautiful book about encryption. So he goes all over the history of encryption. That is amazing by itself. And he ends up in RSA. And OpenPGP, he also talks about it. And he does a very nice explanation on 10 steps of how works the heavy mathematics of RSA. So we can read it together over these few steps. He does the encryption here of one letter. Oops. This is what he encrypts in these 10 steps using really RSA. So we could go over that at the end. It's really a pity that I cannot do the live demonstration of the Drupal module for you today, because we had trouble with my computer that could not connect here. But, so let me go back to the beginning. This module, because it's already a full project, you could, if you had your computers here, but this is not the case, you could do a Drush DL or Drush enable and PROC, and you have it in your machine, if you are brave enough for that. Now, should be safe. So, what it does.
Famous last words.
It's until there are a lot of things to improve on it. Mainly, my next steps is going to be to use custom entities instead of some ugly database tables. But it, and then this will allow this model to be easily integrated all around Drupal with views and rules and anything else. But so far it is not like that, so it's kind of limited. But what it does, user, there is it has some hook menus, 3 if I'm not wrong. So there is one address for the user to create his or her encryption password. And then the user needs to type a password. Password is concatenated with pass hash used as a salt specific to the user. We can discuss this deeper later. OpenPGP.js uses username, email address, and random numbers to create users' public and private key. Private key is symmetrically encrypted AES-256. This is the default algorithm by OpenPGP.js, but it allows to change that. So in the future, if it comes a more secure algorithm than that, we could use, but this is the biggest security we could have so far that is known. Then this is the page, very simple page. I have tested it on several browsers. It's working fine so far. Obviously not with Internet Explorer or Edge. Then
They still exist?
yeah.
Yeah, they exist.
Then once you have an encryption public and private key, you are able to receive encrypted data. But you don't really need to have registered your keys if you are only going to send to someone. Why? Because the asymetric encryption means that I'm going to use the public key of someone to encrypt the file, and the person is going to use his or her own private key to decrypt it. So this is because I'm not dealing with signature here. The sender does not need to have keys. But okay, recipient user needs to have registered encryption keys. Sender user does not need to have registered encryption keys. As we said, it's possible to encrypt the same file using multiple public keys. This the first code I wrote was not like that. Then it has been improved a bit. Now we can encrypt the same file. It is a plan to extend it to not be only cover files, but files are the most difficult part. But we can encrypt any text field or even any field in Drupal could be encrypted like this. Then I can use multiple public keys to encrypt all of the users with their own private keys and their own passwords that were used to encrypt their private keys are going to be able to decrypt this file. So, for example, Mary can encrypt to herself as long as Mary has registered keys. So she could send to herself and to someone else. Public keys of recipient users are loaded by their user IDs in a comma-separated values argument, and then the hook menu gives us that address by default. So file/new. This is also something that maybe could change. This is Drupal 7, not yet Drupal 8, because our client runs a project in Drupal 7, but I hope we'll have some time to make it for Drupal 8 as well. That maybe that the user IDs could come in between file and new, like we have for node ID, and then the operation. So this is the form for adding the file. This is interesting how what happens in behind, because as I said before, the file itself will never be uploaded. Text in binary files are treated the same way. That was easier to do than asking which kind of file was that. Original file will never be submitted or leave the browser. Okay, this when the user is able to press save, because that button is unavailable now, is disabled. After the file has been chosen, at this moment, because when I'm going to send to someone the file, I know already which user is that. So if this user has keys, this will work, and then the browser has loaded the public key of that user already. So from now on, everything happens in the browser, in the client side. So I choose a file. I have already in my form attached to the JS via Drupal behaviors. I have the public keys of the recipient users. Then OpenPGP.js is run. There are some methods on the library for that. With that public keys, the file gets encrypted. Now I have a ciphertext that is the ASCII armored version of the file. So there is a process of turning from a binary file becomes there are some formats. I think I have then here. So this, if I have this and the button enabled, means that encryption went well. And what happened is I have a description there. File was read as a file reader object and converted to uint8 array, quite new for me when I started doing this. Readable stream is started with it and composes together with recipient's public keys the options needed at OpenPGP encrypt options. This is OpenPGP.js library working. And then, if that goes well after save, Drupal gives back an ID for that ciphertext. So that number in the end, 43, is identified in the database as CID, ciphertext ID. There is a control of permissions for the users that are going to access this link. So only the recipients are going to have access to the link on the Drupal side. But even if an administrator comes and masquerades as a user that has access to that link, this administrator would need to have the decryption password. Then now we have this screenshot from the page where the user is coming to access his precious content, and the password needs to be typed in, obviously. This check is made by OpenPGP.js in the client side. So what happened? It tried to decrypt the private key. It was not possible. There are two, from what I remember, from what I have seen, two possible errors. Maybe there are more, but I have faced two. Or the private key or the ciphertext did not validate, or they validate, they were real ones, but the password did not decrypt the private key. So this is the case here. You can type anything that is not the password, you get that error. So interesting, this error does not come from Drupal. It's fully client-side behavior. And then if you get a correct passphrase, obviously, the file will be available here immediately. So it's very nice because you get the file with the same file name, with the same size, and actually the file has never left the machine that has sent it. So Drupal checks if the current user is the recipient of the ciphertext requested. If this is the case, ciphertext is attached to the form at protected content file open ciphertext ID. Ciphertext and encrypted private key of the current user, recipient is loaded in by JS via Drupal settings and becomes available for decryption. First, the private key is decrypted in a promise, modern JavaScript. Then the private key composed together with the ciphertext of the options needed at OpenPGP decrypt options. That is very similar to the previous one that we had that was encrypt. A new blob type octet binary, because as I told you before, everything is treated as binary. object is created with the plain text, getting that plain text, and then it becomes a file. The size is checked against the database. This was a really small thing to be done, but okay, if something went wrong, the size would not be the same. So it stores some metadata in the database. So I'm storing on the database when a user does the encryption, I'm storing how long it took to do the encryption, which client, which browser the user had. A bit of metadata in order for me to be able to debug users. Let's say a user is complaining that is not working, we could study a bit further what's going on. So it stores a bit of metadata, including the file name. And the file name is what is going to be used to generate that link. And then the person not really downloads, but the person generates on the browser a file with the same file name that existed previously. Now, we could talk a bit about asymmetric cryptography in a metaphor that is given to us by Simon Singh, the author of the codebook. So he has this metaphor. So you have a box, you want to send a letter to someone. Then you put your letter inside this box, you lock this box with your locker, and only you have the key. You send the box to the person. What the person does? The person puts a second locker in the box with his own key and keeps with himself the key. And then this person sends me back the box. Now I'm the sender, but I have a box with my letter inside and two lockers on it. I remove my own locker and I send back to the person. Now the person has a box with my letter inside, but locked only with his or her own locker. It's really a beautiful metaphor for that. This kind of I'm not really sure how close this metaphor is of the mathematical side, because I can send encrypted information using double keys, asymmetric methodology, and I don't need to have myself a key. But there are always these two keys. This is also important. The public and private key, they live together. They are the part of the same thing. One solves the other. So it's and now we have these 10 steps, but I don't think I'm in the mood to go through all of them. Yeah, it's nice. I just let you with this reading suggestion that is really nice book. And when you go through these steps, you really understand RSA, and you understand how amazing it is because it's simple. So if you do this with small numbers, because it all relies on this mathematical phenomena of a function that is easy to go to one side but very difficult to come back. And then if you try with these small numbers that are prime numbers, and everything relies on prime numbers as well. If you do this with small numbers, you can go through every step. It's very nice. Also, there is an interesting subject related to encryption that is the philosophical and political consequence of this, because the author of OpenPGP, he is today a professor in The Hague, Phil Zimmerman, if I'm not wrong. He was young when he started doing this, and he was activist in the United States against the Vietnam War. and he was imprisoned more than once. So then there was this encryption wars. That was the situation of governments telling people you should not encrypt, and then it's like he's saying you should not use mathematics to someone. But you can put yourself on the shoes of a government and think, okay, maybe there are some reasons for someone to think that should be the case. For example, you want to avoid criminals from hiding from everyone else. And how strong should be the state? The state should be should have full powers over everything or not? It's a philosophical and political question, not for us to answer. But I hope we will not be forbidden to play with our software. Okay. Any question? I don't know if I'm going too fast or too slow.
How do you protect your OpenPGP library from being replaced by something online?
Yeah, that's an important question. Because what comes to the client is what the client took from the server, right? Because I'm providing a copy of it. So the user could, for example, the user could manipulate OpenPGP.js on his console and to make the encryption fail. And then this user would not be able to encrypt something, or this user would not be able to decrypt something that was sent to him. Then this is it's not tamper-proof. You see?
Nothing is.
Yeah.
But do you use something to at least have some level of tamper resistance?
Not yet. But it is being foreseen by me, actually, to try to make it tamper resistant, but in regard to signatures. But this is another subject. I cannot answer you more about this. But do you have any suggestion? Because these are Rotten Tomatoes throwing session as well.
What I would do as a first protection against tampering is use sub-resources SRI, so that the script that will eventually be loaded by the browser has to match a hash. Multiple hashes.
That is a known solution. It for sure should be applied.
It solves a bit of the problem, not the full problem.
Yeah, but consider the following. So the hash has been checked. The script that is a mimified JS matches it. It's okay. Now the user, before submitting something, he goes to the settings of OpenPGP.js and changes something. The hash has been already checked. The file was correct, but in the DOM, I have different data there, different configurations than what was expected. So not yet, you see. But yeah, at least one level of security would be added using that.
Yeah, that's what I mean.
But with that approach, you can even have an hacker changing the hash of the. So changing both, and how do you secure the hash itself?
Well, you transmit the hash before the file. And the file is, you can even protect the file, the HTML file itself, with it if you implement it. So you could have take the hash of your DOM, and then use JavaScript to check that it's the same. I've seen implementations of this, not ones that I like, but
that is interesting.
Yeah, but
a hash
it
a
made
hash
it so
of the
slow that
entire DOM.
it's not practical.
Yeah.
That doesn't prevent man-in-the-middle attacks. I mean, let's say the government.
No, the TLS does. So you have a TLS connection that will buffer event
Yeah.
and in the middle.
Go do that in China and
Yes. I have another question.
Please.
Have you looked into maybe implementing not this OpenPGP not in JavaScript but in WASM?
What? What's that?
In WASM, the binary format.
I did not think about that.
Because that would be a lot harder to manipulate. JavaScript is, because it's interpreted, it's a lot easier to dynamically change.
Uh-huh.
And, WASM is only, well, basically read once and then just executed.
And would it be possible or easy to have OpenPGP.js running like that or not? Because I'm not
what you would need
aware.
to do is you would need to compile the PGP library itself,
Uh-huh.
the OpenPGP library itself, again as a WASM, and that has to be done in one of the languages supported. So there are a lot, but I'm not familiar with all of them.
I see.
It's often called WebAssembly.
WebAssembly, that's the name. Yeah.
But is this not a bit of kind of doing it obscure? Is a bit of approach of obscurizing something? No?
No, because you can, while it is a binary format, you can transform it into an ASCII format which you can read. It reads a bit like assembly,
Uh-huh.
and yeah,
Well,
you
that
can even debug it then.
very interesting.
So
And it's supposed to have performance advantages as well.
Don't
if you're worried.
don't let my manager to know about this possibility.
Just tell him you came up with it yourself.
you could consider it, but it's not a ready-made solution. And WebAssembly is a new technology, so we're still figuring out how to implement it. But what I understand about it, OpenPGP would be a prime target for using WebAssembly, since it's just a cryptographic library, so math. So all I would need is I need a way to configure the thing and send it the byte stream, and then I get the encrypted cipher back. Or it's something else that I wanted to do.
Uh-huh.
I don't have to interact with the DOM or anything else.
Uh-huh.
And that can still be done by the plain old JavaScript.
Yeah. Yeah, but as long as you can get the ciphertext could be published. Everyone could see the ciphertext.
No, I mean the library will then, which produces the ciphertext. will
in
then be-
the moment that it is producing. I see.
Yes.
Yes.
And
Yeah.
since WebAssembly runs in a different part of the browser engine than JavaScript, even you can't read its memory using JavaScript.
Uh-huh.
You can only read what is exposed.
Uh-huh. So the attacker would need to attack the machine that the user is going to use. You need to compromise the browser. You would need to play inside the browser. Yeah.
So
But if that happens, an attacker would, if the attacker does so much, there was a easier step for the attacker. He could just read the keys of the password. Then
yeah, well,
it's not the scope of the cryptography anymore. You see.
no, but the main thing is because JavaScript is interpreted and
Yeah.
reinterpreted.
Uh-huh.
All I have to do to mess with it is inject code into it.
Yeah.
WebAssembly is only processed once, and
I
then
see.
it's machine code.
I see.
So at that point, you have to inject machine code somewhere.
Way more difficult. Yeah, I see.
The browser has protections against it.
Okay, thanks.
How easy would it be to integrate with credential storage solutions? For example, like Vault from HashiCorp. So instead of knowing the password itself or the cipher, it would be stored somewhere else, and then
No, this is assumption you cannot do on this approach.
Okay.
It's assumption that the password will never be stored. The encryption password. The user authentication is another thing.
Yeah.
But the encryption password does not get stored.
But instead of myself knowing it, it's some other secret manager that knows the password. So it could be something very complex, which I don't need to remember, of course. and then there is a trust between these two entities. So the site or the OpenPGP and Vault, for example, for ease of and then I just allow Vault to do this decryption itself.
Well, if my manager asked me to do that, I would scream now against.
Okay.
Yeah.
Well,
But there is one interesting thing that can be done about sharing password, not really sharing, but storing in a way that could try to be safe. That is the following. They have, at least on the movies about nuclear war, sometimes you see people, the president and the vice president, they both have a key, and the keys only work together, right? There is something we could in a not difficult way to do that would be like that. For example, I want every file to be sent to the recipient, the sender chooses, plus administrator. Meaning, thinking that in the future an administrator could want to audit what is being stored on the server. Okay. But then someone could compare, okay, what happens if this administrator, the person himself is compromised because it became a spy or something like that. Oh, okay, let's put 2 administrators. Then what could be done very, very easily, and the current architecture already allows that. The first administrator would come and type in that password, what is it? The first administrator would come, a person, would type here 5 characters. No one else knows. The second would come and type the more 5. And then we have 10 characters password plus the hash of the user that is here, not being seen. Then each of these person, if they don't trust themselves, even they could write and put in a locker each one of them, and in the future, if someone wants to break the lockers and get the password, they would be able to.
For example, for solutions like credential storage managers, they do things like key rotation automatically, so it's something that you don't need to take care of yourself. And you can even have like a master key, which is stored securely in that vault, and it's only get out just a part of it, just the public part, and to encrypt the file. So it could be that your file itself has, instead of having just one key, which is the user key, you can have 2, because PGP allows for that, to have multiple keys associated with the file. Yeah. And then if you need it, then you have some other master key to decrypt the file. That's why if you can integrate with these kind of solutions, might be useful.
I see.
And a broader range.
There was
something to consider.
Okay, thanks.
I have another question. Can you provide more context about you talked about the customer. I can imagine end users not wanted to use this, but what kind of provider of services like that? Well, why are they asking that? What's the context? The provider of the system itself.
It's a requirement that says in the worst case scenario, meaning someone took over the server, we don't want the data to leak.
I was going to ask about the password. I see you've got the password strength indicator on there, about avoiding users just choosing really bad passwords, because obviously if your system can be really, really clever, but if people use utterly terrible passwords, then they can be brute forced easily and that type of thing. Yeah. So I guess you would have to use client-side code to be trying to ensure that they're not using really bad passwords.
We could do that exclusively client-side. Not being enforced now, but it would be a matter. We could not. I'm not enforcing, not even length. So, but if we choose to enforce a length, we could choose to enforce other criteria also. Yeah.
Which I suppose the more you try and enforce, good quality passwords, the harder it gets to stick to your idea of it staying in the user's mind. Because
Well, you could use passphrases.
yeah,
The long tall fox jumps over the Dutch windmill.
Yeah. But there is one pitfall on this approach. If the user loses the password, the user is not able to recover at all.
no,
Not anymore, never.
yeah,
So, all the data that has been sent to him will need to be sent again.
yeah. And sorry, I just said one other thought about the metadata on the file. So I think you said that you were storing the file size outside of the encryption.
Yes,
And
yes.
also the file name, I think.
Yes,
you said.
yes.
So I wonder whether, in some circumstances, those bits of data, particularly the file name, might be considered sensitive in itself.
Yeah, this is interesting. If it would be opened for her leaking, if that is the case.
Possibly,
Yeah.
If it was, if it says Alice's CV or resume or something, then you've got
Or you
a guess
could-
of what the
You
content
could
is.
put some nice honeypotty names
You could,
in
yeah.
between, just to give them something to think about.
Yes. And do you?
Unequal file.
So you're encrypting the full binary content of the file. So when you decrypt it, because you talked about the MIME type being an octet binary.
Yeah.
When you decrypt it, then you've got the header for the file to actually. I'm just wondering how the browser, if you're downloading the file, how it recognizes the MIME type once you've decrypted it. But it's just because it's in the header of the file itself.
Yeah, honestly, I did not dig so deep on the process to give you a proper answer to that. But interestingly, it works well if you have a binary file or if you have a text file. It just works well. You get back a text file if it was a text file, you get back a binary file if it was a binary file.
Right.
Probably the MIME detection of the download will do it.
Sorry?
So probably the MIME detection of the download function will do it. So as soon as you press download, there's a MIME detection of the received file, and this
Yeah.
file will be received by the browser.
Yeah,
So that one does the MIME detection.
yeah.
Right.
I have another question. Could you use something like keybase.io as a way of using that as a source for the keys you use? So like the PGP keys.
Are you talking about storing the key ring, that is this
The public
pairs
key.
of keys,
The public
storing
key.
every
it's
other
the
place?
receiver he has a keybase.io account. I want to send a file to him or her.
Yeah,
Could you use
this
that?
approach, I thought about this for a while, but this makes a burden of the user. You make the user to be aware of what are encryption keys. And we wanted it very user-friendly in a way that for the user it's like WhatsApp. It's like that other messaging, the Telegram. They do just client-side encryption. The user does not even know about that. And we wanted that.
Okay. Would be a nice addition.
Okay.
Let's close this session for now.
Okay,
I
thanks.
think there will be many other questions and topics during the Cycles walk a little bit later.
Okay.
Personally, I'm really happy to see you here.
Thank
and,
you for having me.
And also like to get an applause for the topic.